Hello and welcome back to another episode of I guess I'm still calling this Explaining Our Agentic Future, the name that I obviously didn't put much thought into at all. This is going to be a a very different well maybe you should ask me about how we came up with the name TrustGraph, because that's another one. Boy, we didn't put much thought into that one. It's funny how that works out. Um Very different episode from our last episode where we, dove really into AI regulations with a lawyer, Rick Borden. I'm now joined by somebody very much not a lawyer, are you?
No, thanks for having me. Definitely not a lawyer, far from that.
Well, if you're not a lawyer, who are you and what are you?
That's a really good question to start with. Who knows? Probably an agent browsing around, figuring out how to make sense of knowledge.
Oh, well, that's a good question. So I think but you are Marko from Memgraph,
Yeah,
and
yeah, yeah.
I always the thing that I'm always interested because I have such a odd journey on how I got into knowledge graphs. I definitely backed into it from the most non-traditional way possible. So I'm always interested because it's kind of it's a very unique field of study. How did you get introduced to knowledge graphs?
Yeah, that's one of these questions. So probably super early, because I have like a large background in math and computer science. That's how I got introduced to the graphs through the school and early on figuring out like interesting graph problems. But yeah, then later on the whole knowledge graph concept landed when yeah, my co-founder and I started playing with graph databases. Then the whole field of knowledge graphs kick in. That's kind of probably how I got introduced.
So did you formally study like information theory, or just more interested in the mathematical side and how that applied to computer science?
Yeah, actually, not. Yeah, it wasn't like information theory wasn't like a field of study of mine, but just like as a part of the university programs and university courses, that was part of it. So then, like some of these things are actually formalized as a graphs,
Hmm.
and then there is also like graph theory as a separate course,
Sure.
and that's where like I guess the formal knowledge about graphs started. But then later on, there is a lot of standards on the internet talking about graphs, leveraging graphs, different standards, different ways how people are interacting with the graphs.
Sure. And that's interesting because even though we're talking about knowledge graphs, a graph more is, as you're saying, a mathematical concept of just ways of representing connections. You can have directional flow. It can get as complex as you could possibly want it, which kind of brings me to a question that I find myself asking a lot. I find that the word knowledge evokes confused responses from people. We People have a really good grasp of what data is, but when you say knowledge, they don't seem to understand the differences. So when I say what's the difference between knowledge and data, how do you think about that difference, or do you think there is?
Yeah, I think knowledge is just some kind of data which is organized in a certain way, and I guess in a given even in a given topic or a given area, there is certain knowledge people extract from data which is connected to that area. There has to be some kind of again connections between different facts and different uh, yeah different data points in that particular field. Um, I think there's definitely a difference. The question is like, how do you formalize that? But there has to be some
Mhm.
kind of like in different domains, you have different, you have maybe similar data points which are connected differently and stuff like that.
Yeah, you mentioned a word that I always find is very, very relevant to what the word, the work with AI and LLMs, and that's the word, fact. And fact is such a challenging word these days. So, I think about, what is the foundation of knowledge? Is it fact? Is it evidence? Is it observations? Are these all just semantic struggles of the inexactness of human language? How do you think about these problems?
Yeah. Um, that's yeah. I mean, these are all like very connected terms, like, but
Hmm.
yeah, and a different. I guess the biggest challenge is like these facts can be organized in a different way, and then
Hmm.
it's a challenge how to actually like know all the facts, connect all the facts, how to make any sense in a given in a given situation, how do I extract useful so how do you extract some utility from these facts
Hmm.
and make sense of them. And that's, I guess, what knowledge is like in a given context. How do you employ given context to make something out of that?
Right. So, and that's one of the things that I often wonder is when we talk about data, we think about, we're trying to create, calculate some sort of analytics that we think that we're going to help us understand some situation better. But when we talk about knowledge, we talk about these more vague terms like understanding or, insight.
Yeah.
When we calculate a metric using data, it's pretty obvious, when we're done. But, when do you know that you've reached understanding or that you've reached insight?
Yeah. I mean, there's also one other thing that pops into mind is like people have different, or people have the same, let's say people have the same data,
Hmm.
but the concept of lateral thinking is interesting because people with similar knowledge can make totally different conclusions out of that. And that's why I guess what the knowledge is, or like it's also the ambiguity is evident there because with the same data, people can make total different conclusions somehow. And that's interesting because yeah, why is that so? How do you make that? I guess that's uh, yeah, that's more on the ambiguity side.
Well, yeah, and that's, I think that's, very much, yeah, the intelligence process. If you take data and then you come to interpretation. What you just said, is just, I think that's really the interesting part is like how two people can take the same data and interpret it, a different way. And, what do you think the role of technology, plays in that?
Yeah, uh, I mean, definitely technology on that side should help us figure out like reliable decisions and make something which is always similar for or always optimal in a given case, because people usually don't make, or a lot of times don't make optimal decisions because just of the lack of I don't know of recalling specific things or too slow of a processing power or whatever. Sometimes it can happen. It can happen that it doesn't work properly. So that's where I guess technology kicks in because you can make reliable, accurate decisions. Let's say.
That's an interesting topic because I see so many people in the AI space, and they talk about these modeling these models. Wow, that was really creative of me. They talk about, trying to design these models based on human cognition. And, it sounds like, you're very well aware of behavioral economics and how well this has been studied for a very, very long time, that we're not we're far from perfect decision makers. We're very imperfect decision makers, that we're prone to so many fallacies, even when presented with valid, good data. The conjunction fallacy is one of my favorite ones, of how people struggle to just do the most simple calculation of probabilistic and, so many people don't understand that if the probability of choice A is 50% and the probability of choice B, if two scenarios is 30% and there's an and, it's less than 30%. They actually think it's additive, which is kind of mind blowing. But that's a really interesting one that I don't know that we're going to be able to solve the answer for today. But one of the things I did want to talk about with you being, at Memgraph and one of the founders of Memgraph, is one of the things I think is interesting, speaking of semantic ambiguity, is we have so many terms for representing ways we store data now: data stores, databases, data lakes, data warehouses. And I see all these and I go, I mean, what's the difference? And I know if I say that to a data engineer, I'm probably going to get punched in the face. And I know at the technical levels there are differences, but to the user, to the end user, they all look the same. So, how do you think about that? Like, what are the differences between all of these, and where do those differences really apply, and why do they matter?
Yeah, I mean, all the terms you mentioned, I mean, because of fundamentally, that's all the same data or the same knowledge, if you want as well. But the challenge is, it's always, again, how do you scale? What are the typical use cases? For example, database, data lake type of thing. So there are different constraints also on the technology level. I know a given relational database, traditional relational database solves a particular problem of, I don't know, fetching data with SQL language in a quite good way. But when you have a lot of different data coming into the system, data lake is probably a better technology because it's slightly different. It solves data storage problem in a slightly different way, from a slightly different angle. Of course, it doesn't provide all the guarantees because there is always some kind of a trade-off. Yeah, the problem is always in computer science, there is always some kind of a trade-off. Something works better. On the other side, something will work not so great. So, and then people are just trying to figure out, for a given context, what's the best technology, and then came up with interesting names for very similar concept. And I guess there is also like multiple layers of abstractions. So, I mean, yes, it's all data, but a given implementation of a data store can be like very different.
Well, I guess one of the reasons I ask is because, sometimes I think if you think of a knowledge graph, and,
Yeah.
if we think about a knowledge graph as, a set of nodes, edges, or even we set of, triples, SPO, however we want to think about it. And we think about, that's just a set. I think about it, well, that's kind of like, a data warehouse, a data lake. And then when you take something like RDF or Cipher even, and you start labeling, that's kind of like a warehousing, but that doesn't seem to be how most people, think of knowledge graphs. So I guess, that's a good segue into, a knowledge graph like Memgraph. Like, how is it actually structured, in the internals of it? Like, what is it most like? What is it not like? How does it fit into these ecosystems? I think that's a good question. A lot of people don't even really understand as I hear this, knowledge graph, but, where does it fit in with all of these things that store data?
Yeah. Knowledge graph, again, knowledge graph is like super high abstract, high level term, which can be applied to, I think, everything. Because on one side, with graphs, it's a very interesting thing that you can model anything. You have these nodes and edges, node and relationships, and it's possible to model any type of data. And then people come up with like a knowledge graph term, which is essentially like a bunch of data connected together. But yeah, the question is, what's the actual queries which are useful to the users? How do we extract, I guess, some analytics, some knowledge out of the data? I mean, and Memgraph in particular, we initially just took like a label property graph. That's a it's actually very well defined structure for representing a graph. I guess there is also multiple ways of representing a graph. A label property graph is one of them. Because yeah, initially it seems to be like very natural way of representing a graph with additional structure. For example, these labels on nodes and edge types on edges, and properties on each node and edge, and kind of we started building based on that structure, and then we came up with like optimized implementation of like optimized in-memory implementation to run some of these queries super fast. So that's kind of how we started. But then with label property graph, you can also model a bunch of things. You can say, oh, for this CSV file, or I know this data set I have, you can just take it in, assign certain labels to certain nodes and edge types to certain edges, and then yeah, play with the queries.
But I guess, I mean, like, so, but how is this actually? So it's a labeled property graph, and get in, when we talk about queries, okay, that makes a lot of sense. But how is it actually? What is this stuff like looking? If we actually dig down, are you using like some sort of column structure to store the data, or is it um, lots of tables that are joined together? Because I know there's a lot of different ways to do this, and I'm always just interested in what it actually looks like when you really get down into the internals of these, say, whether it's a data lake or data warehouse, data store, database. If you dig deep enough, how are we actually storing this data?
Yeah, there is a lot of ways. Usually, I guess, yeah, in the relational databases always have their own ways of representing these tables, and then relationships are done at a query time by running these joins. But in the label property graph and in Memgraph as well, there is a way of making these connections between nodes at creation time. When you create a graph, you have to say, oh, these two nodes are connected this way, and then under the hood, so we built completely from scratch solution without using any like a third-party key value store, or I'm just making up, because some of these some of the databases are built by using
Yeah, sure.
key
I mean,
value stores, let's say.
and so many things
Uh,
these days are built off the back of open source projects. But so you didn't find
yeah,
anything that you thought was a good starting point, and you wanted to start from a clean sheet of paper?
yeah, we started like super clean on that side, building our own um, yeah, primary storage for nodes, primary storage for edges. It's all like implemented in C++. It wasn't for the same. I mean, we kind of it was probably also premature optimization, if you want, or if you will. But it's kind of because we wanted to get as much performance as possible from the system. Then we started building these things on our own and kind of optimizing specific pieces of it. Um, uh, and again, because the whole thing is in memory, to squeeze as much as performance, that totally makes sense. But yeah, it's not. It's just very specialized storage for label property graph. Um, Essentially, between little chunks of memory where node data is stored, there are direct pointers to another nodes, which you can follow. And kind of the optimization part was to how to run these traversal queries like BFS, DFS. And that's more analytical. So in the traditional database nomenclature, it's how to run these analytical / OLAP queries as fast as possible. That was the goal, to get done as best as possible.
That's really interesting to hear that you started from scratch, because when I hear somebody say, we designed this from scratch, clean sheet of paper, that makes me think you were really unhappy with the way people were trying to solve this problem. So,
Yeah.
what problem was it that you were trying to solve that you didn't think, any sort of data stores or databases or even some of the other knowledge graphs of the time, didn't solve those problems for you.
Yes, initially it was kind of it was very interesting to observe that for a given data, you need to run these, let's say, deep path traversals like BFS, DFS to extract some knowledge. So let's say from a given node, if you traverse a neighborhood of that node, basically just following the connections, you are searching for something that's a given, I don't know, let's say, and that was really the workload. So in the fraud detection case, you have to find something which is not regular, which is anomaly or which is suspicious in a given neighborhood of a node, and then running these queries on like a graph databases were super slow at the time, so we couldn't figure out the proper speed out of the systems. And then, for example, existing graph databases were like slower than Postgres, like a relational database, which by definition it's not optimized for these type of things. And then we just took like a few, I don't know, interesting ideas and figuring out how to run these queries as fast as possible. And then the solution was like in-memory engine built from scratch, optimized for these types of traversals. That was kind of the start.
So latency was really the ability. Was it so? But it sounds like it wasn't just latency. You were specifically looking for more complex queries where you're not just querying, um, you know, primary relationships. It seems like you're trying to find some of those relationships separated by many degrees of separation, and maybe, like as you said, that are more on the anomalous range. Is that kind of why is that kind of the things you were really optimizing for?
Yeah, I mean, yeah, some of these, let's say, low latency on more complex queries. I mean, these queries you can be expressed in a very compact form, but yeah, in practice they're more computationally heavy, because as soon as you start exploring the connections, you end up analyzing, and that's why it's called analytical queries. You started analyzing a large chunk of data set, which is then challenging, or filtering a bunch of data in a given data set, and then latency on that side is kind of critical.
Well, when you started Memgraph, was it always, did you have this vision for it to be a company that would be here almost a decade later, or was it just trying to solve this problem you had at a point in time? What was really your vision when you first started trying to solve this problem?
Yeah, I mean, just solving the problem, just figuring out how to make that as best as possible. But then with software, it's usually, I can publish that. We can publish that easily, so that other people can also leverage that. But it was mostly like how to build technically, how to solve that problem in the best possible way, or in the optimal way. And then yeah, later on, how to publish that, or like put that public so other people can also use that. That was the initial thing.
Well, so I guess that's a good question though. Where did you see traction? Did you publish, and then did people start saying, "Hey, this actually solves a problem of mine"? Did it start to grow that way?
No. Then, like, of course, it takes a while, because the main issue these days with any, I mean, that's my opinion, but with
Hmm.
any sort of software projects, and again, DevTools, if you target
Hmm.
like I mean, however you call that, DevTools infrastructures type of software, or anything which is a
Oh,
bit
yeah.
lower in the stack, because a lot of capabilities are expected from developers to actually use that on a bigger scale or in production, or there is like like a really steep curve to actually get to a point where the system is usable, or if you want like MVP, like from zero
Hmm.
to MVP, it's really, we massively underestimated how long that is, how much, what is like a MVP, and then it takes a lot of time to actually build something useful. That's yeah, what I
Well,
think
I
it's
guess
the most challenging.
Well, then I guess how long did it take you to get to that, what you were considering an MVP?
Like like it took us like a few years to actually build from zero to something which is kind of respectable enough that people can use it in production and figure out how to make, let's say, like, yeah, a few years at least. While expectation was, yeah, we can do that in 6 months or something like that, which is
Hmm.
super short time.
Well, did you have people that were using it, or did you have a community back then that was, able to give you feedback so that you were getting signals on what was working and what wasn't?
Yeah, it was also like kind of early mistake. We didn't start building community in the first place. It took us quite a while when we started when we did the open source and started to build a community. In retrospective, we should start building that much sooner, and talking with potential users and talking about the challenges and like whatever whatever on the, let's say, developer side or yeah, basically speaking to potential users much sooner in the whole life cycle.
I feel like, with TrustGraph, we did make a good decision in that regard, but I would say that there's so much, kind of what you even alluding to, that there's just so much noise with so many projects and so many alternatives. It's just so hard to get people's attention to give you more than 15 seconds glance at, your repo. And to me, and maybe that's just because, it's what I do every day, it seems, worse now than ever before. But is it maybe? I mean, did you feel like that was a problem even when you were starting out with Memgraph? Is it you were drowning in the sea of alternatives? And if you did feel that way, how did you kind of go about solving that problem?
Yeah, I think it was similar. I'm not sure. It's probably worse today, but it was similar, like, I don't know, a few years ago as well. But yeah, the solution is, I mean, um, yeah, grind on that side and figure out how to be the best on what you're building. But maybe a question like, what do you are you targeting developers, or is it more of like yeah, some other type of persona, some other type of user? What's the target user for the Trust Graph?
That's a good question. For a while, we were thinking about developers, but I don't think that's really the case now because there's so many developer tools out there, and we're not really helping people code. And since TrustGraph is really this end-to-end infrastructure, it's
Hmm.
it's not really something it's not designed for there to be a lot of development. So it doesn't seem natural to go after developers, which has kind of left us going, very rightly asking the question that you've asked, who are the user personas? And that's one of the reasons why we've been talking to people like yourself and trying to, because people that are interested in knowledge graphs, knowledge analytics, trying to come to understanding of knowledge. Who are those people? How do we connect to those people? We've thought about going after some really direct use cases, and those all kind of have their challenges as well. I mean, legal is an interesting one, which is very interesting because we're going to do a demo on the legal field tomorrow during
Yeah.
well, actually, excuse me, since this is going to debut after we did the community call, we just did this amazing demo of TrustGraph using the UK legal data set. And I'm sure it went amazingly well. And one thing that I talked about and mentioned is that I initially thought that legal was going to be one of those domains that's going to be absolutely just disrupted by AI. It's going to crush it. And now I don't think so. And I don't think so because it's a field in which you have to be able to prove that you're not going to make a mistake. Because if you're using AI
Yeah.
to do your research for a case and you misquote case law or you make an interpretation that's not correct and you end up losing a case, and that could be money to your client, or if you're in criminal law, if
Yeah.
somebody ends up being found guilty that should not because of a mistake that an AI made, an AI system made, I could only imagine the malpractice lawsuit. So, and I was talking to a lawyer friend of mine just the other day. I think that the big law firms are definitely looking at this and thinking, yeah, until somebody can make some sort of guarantees on the accuracy and reliability of the system, it's going to be that's nice, but no thanks, which means you're left with probably much smaller practices who are willing to take the risk, but they probably also aren't going to want to pay for a tool. So, where that they seem to be misaligned in terms of financial incentives, which is why, one of the things that we're focusing on or want to focus on is, can we start to use graph analytics, all the data that we have about knowledge once it's been ingested in the graph, to start to be able to measure the performance based on this knowledge. And something Mark and I have been talking about this a lot, and we're starting to dig out old papers on information theory about how do we people have been talking about these problems for a long time. How can we maybe potentially go
Yeah.
about solving them? And the the bad news is, it's pretty much a clean slate right now. There's not a lot of
Yeah.
solutions out there, which is also the good news. Anything we propose kind of puts us in the lead, right or wrong. So, that's one of the things that we're really interested about with, a lot of the really sophisticated algorithms and techniques in a tool like Memgraph, is ability to leverage those analytics and start to be able to, interestingly, take a more data, using the word data, where we calculate data, where we calculate analytics, where we calculate metrics that we use to model this behavior, which it makes people feel more comfortable. Whether it should or should not, it's kind of a different kind of a different topic. But so that's kind of a very long-winded answer of where we're trying to go with
Yeah.
TrustGraph, and the the thing that we think we can do that makes us a little bit unique.
Yeah. And I mean, AI, or LLMs in particular, kind of bridge that gap or shorten the gap between developers and, I mean, not everyone,
Mhm.
like with a prompt or a chat as a user interface. Definitely, like, more people can become a developer, or in
Mhm.
air quotes, like, kind of have the
Mhm.
ability to build systems or something like that. I think the efficiency is much bigger on that side. But and then I mean, you can do horizontal stuff, building additional tools or building additional
Mhm.
building blocks for that. Or I guess vertical plays kind of figure a use case or more specific use case like legal, and then build something which is more specific. But yeah, I'm kind of thinking a lot about how do you evaluate these systems, whatever you build, for
Yes.
example. And that's, I think, to me, seems like a key problem in all of these systems.
Yes.
While, I mean, if they if you want to apply a system in the real world, like you really want to make sure that it works in a given cases, and then you have to build for that, test for that, evaluate for that. Kind of building the evaluation pipeline is like a critical thing. Let's say, how do you make interpretation of a law? I mean, you have to really evaluate a bunch of interpretations. So in a correct way. That's a challenge in the domain. How do you do that? I don't know. That's something like an agent, let's say an agent in the legal case, have to be trained for somehow, and there has to be some kind of compute power spent on that problem, and probably also having human in the loop, because only humans currently can give the right feedback to these systems. That's also a challenge, how to make that efficient and how to train on a large scale these systems.
Yeah, I totally agree. And this is something that we've been thinking about quite a bit, is that, as you said, the barrier to entry to being a developer now is lower than ever before. There are so many frameworks, there's so many tools that where you can launch an agentic system, you can do it in a matter of minutes. I mean, sure, TrustGraph is scalable, enterprise grade, but we are by no means the only way to do this. We've made very specific design decisions for, our philosophy, but we've been really thinking, but like you said, how do you test these agents? How do you know that you can trust these agents? And we've been really thinking about some concepts along that regards. I was thinking even today about in an agent flow where the agent is actually taking, like doing the intermediary steps, and it's thinking and it's observing, and you can see its thoughts. As you said, with the human in the loop, giving the human the ability to say, this thinking looks good, carry on, or go like, no, I don't think you're thinking about this problem in the right way, or maybe kind of go, I can't really tell. Because if you start doing that, you can take a Bayesian-like approach where you can start modeling the trust of the system. How much trust do you have in this agent? Thumbs up, hey, that looks good, goes up. Thumbs down, ooh, not so much. So you can actually begin to think about, modeling the trust. We did this actually last year. We were working on something totally differently, and I came up with this really strange way of calculating what I was calling a trust index, which, believe it or not, was based off of chess elo. And that's another long discussion why I did it that way. And the thing I learned was that if you show somebody a dimensionless number, and then based on a choice, it goes up or goes down, people get really confused about that, and they didn't know how to interpret it. They felt very uncomfortable. So I learned that lesson. It can be underneath the hood, but showing people that number and then going up and down, that spurred a lot of questions. So I have lots of experience in what doesn't work, but I can't say that I know exactly what works. That brings me up to a really good point I wanted to ask you. Because we have these grandiose visions for TrustGraph, and we have the things that we think are important. So were there any things that you thought were really important in your vision for Memgraph that maybe turned out to not be as important as you thought they would be?
You mean in retrospect?
Yeah, in retrospect, like things that you thought, like, this is a feature or this is a design choice, that this is going to be a real difference maker, that turned out to just not really, it didn't work out the way you thought it would.
A lot. Basically, I mean, it's a biased view probably, but we developed so many features in the system, which, I mean, were not used a lot, which are not super useful in general. I mean, as we grow, as there is more people using Memgraph, then these features came into play really nicely. But initially, the problem is how do you, and again, you have very limited resources, very little time, and very little feedback, very little input to prioritize on. And then it's super tough because you only have like basic one data point for everything, and it's very hard to prioritize. And then you build a lot of things which are completely not, I mean, you build a lot of things and most of the things make sense, but kind of order of them doesn't make any sense. and then later on you figure out, oh, it would be much better to build this way, or this, I mean, in this order, or this was completely irrelevant, and yeah, stuff like that. Usually, yeah, order of things and building stuff faster, that's usually a regret. But yeah.
Was there any one that sticks out? Because for me, it's, the trust index that I came up with. And I was so certain that you show people this trust index score, and depending on the decision you make, how it goes up or how it goes down, I thought people would go like, oh, this is amazing. This is what I've been looking for all these years. Now I understand how to make decisions. Instead, people went, huh? I don't get it. So was there like one thing that really sticks out for you like that?
Yeah, I mean, in our case, we don't have, I mean, because we didn't build like okay, there is a UI, and but we didn't have these specific concepts like trust, for example. That's because we build like a lower level tool, let's say. We don't have these, or at least I can't recall now examples like that. But yeah, usually I had now a feature in mind, but it went away.
Well, it must not have
Yeah.
been that egregious then if you already forgotten about it.
Uh,
Because believe me, I will never forget the reactions we got when we showed people the trust index I had created. It was a resounding no amongst everybody we showed it to. There was not even a hint of understanding. There was
But was it
every
like because I guess trust index, it can be also, it's a bit ambiguous. Was it the ambiguity of it, or what was actually the problem with it?
it seemed like everything we people just really
Mhm.
just the idea of capturing enough, trying to capture something like maybe it's because we were trying to model trust and trying to model trust with a word just made people inherently uncomfortable. I'm not sure. Maybe if we'd have tried it with some sort of other metric that's more measurable, that people would have reacted a little bit differently. But so, I mean, I kind of thought it came about a lot because I'm thinking about video games and how if you play a video game and you talk about your skill, it's often a number and it's dimensionless, and people are totally okay with that. And I thought, or even chess elo, like I said, I based it off of chess elo. You have a score. If you're an
Mhm.
average player, I think it's what 1,000 to 1,200. If you're a grandmaster, maybe it's 2,300, and if you're a really poor player, maybe it's 500, 600. And everybody seems okay, that's how you measure my skill. And I thought, well, we can use this same sort of approach to measure trust. And
Mhm.
the feedback was not good,
Yeah.
not
I mean,
positive.
the thing that pops into my mind with these things is, let's say, I was reading the other day a research paper how to evaluate answers from I
Mm,
don't know, a system. But the problem is there is so many metrics. So like correctness, consistency, coherence, trustworthiness, bias. There is so many of these metrics. And now when you talk about this, it's kind of, for me, if you show one thing, that's like only a subset of things, and who knows what people expect out of that, and then that can go wrong. I guess there has to be, yeah, more metrics involved, and then people. But again, the problem is understanding of each metric. I bet people have different understanding of whatever you put there as a name for such a thing. So that's also a challenge, I guess. There has to be
hmm
like a really big info icon there, and people have to read. So
Well, and one of the reasons the direction I come at this problem is because my expertise and all my experience in risk management and different
mhm.
ways of assessing risk. And if you've ever dealt with really complex systems, assessing risk as high, medium, or low very quickly becomes it's not granular enough to make really
Yeah,
good decisions. So you start coming up with these quantitative scales.
yeah,
And but what is a quantitative scale for risk? So some people come up with these dimensionless numbers. Like I remember one time I was working with a team and they said, well, the risk is 900. And I go, okay, what does that mean? Is that good?
yeah,
Is that bad?
yeah.
If I
What's
reduce
the
it to,
scale?
yeah, right. If I reduce it to 850, is that good? Or if I do I need to reduce it to zero to be like, what does that mean? Um, and I think that's a really interesting challenge in that space because again, kind of what we're going back to with trustworthiness of AI and knowledge-based systems. People want to know, like the lawyers, they want to know, can I depend on this system? Can you provide me some sort of guarantee on accuracy and reliability? And we both know they're looking for a number. They want to see a number. How do we measure that? And I don't have an answer for that today or right this second, but I think that's definitely that's the problem to solve. If we can solve that problem, then we've got something really, really special.
Yeah, yeah, definitely.
But, and that kind of brings me to so you know what? I'll give you a choice. I had two topics we could talk about. One of them I think is we could either, one of them is very knowledge graph specific, and one of them is a little bit more forward thinking, and one of them is ontologies or systems as black boxes. Which one do you want to talk about?
Sorry, like what was the forward thinking one? You
Well, I
have
think
knowledge graph.
I guess they're a little bit. Well, I guess there's a little bit of I could maybe shoehorn these both in together in a way. Is that to me, and this was a little bit what I was saying earlier with data stores, databases, data lakes. To the users, these systems look, like black boxes. There's an input and there's an output, and what happens in between? Well, I don't know. There's just this magic that happens on the inside. And I because I look at Memgraph, when I open Memgraph Lab, there's a tremendous amount of functionality in here. So, just to call Memgraph a knowledge graph is really doesn't really accurately depict, that this is a much bigger system with many, many other integrations. That's just more than, I load in triples and I query them out. There's much more going on here. And I think this is even becoming more of an issue with, AI and how all of a sudden we're able to piece together these systems that do tremendous amount of function in ways that's hard to describe to people. And, that also even links to, ontologies of knowledge graphs that ontologies were kind of created because we needed a way to find very specific information and very specific structures. And now with AI, maybe we don't need those very specific structures anymore, that we can find data using new techniques. And I just wanted to, how do you look at this going forward in that, how do you explain, 5 years from, well, maybe not 5 years now, but, how do you explain to people, what Memgraph, for instance, does when it's so much more than a knowledge graph? And as you try to put more functionality into it, how do you, we meet in an elevator, how do you describe it to me?
Yeah, you mentioned that concept of a black box. That's interesting because, yeah, you have that prompt or whatever is the UI, but I think UI is massively simplified these days and kind of everything is blended together, like code and data, and also LLM is a huge black box because it gives you anything out. You ask for something, you get a bunch of different things out. But I think there is a need to actually open that black box in certain cases and figure out what's there or how to tweak it to produce the best results for you or for the organization or what have you. For example, like having the right privacy there or having the right level of personalization. I mean, it's not the same if you are an engineer, you expect certain answer. If you are a finance person, you need for the same prompt, you expect totally different results there. And how do you tweak that? How do you make sure, especially from the organizational point? So from in the enterprise context, if you have an organization and you want for all of your people to have a useful tool, there is certain level of tweaking of the system or specific rules in the system which will give you the best outcomes there. And I guess, yeah, that's where Memgraph fits in. I probably don't have like the best answer for it, but kind of having all these tools built in so people can tweak in specific enterprise cases their knowledge graphs and having the ability to tweak that black box in the best possible way to give the answers from all of your data. Some of that data will be inside Memgraph, but most of the data probably won't be inside Memgraph because you have different stores. I think, yeah, there is no way that there will be like one data store in the world. There is just not such a thing. So probably there will be a lot of integrations with different systems and try to wire data together. But again, Graph is very suitable for these things because you can actually make connections. Oh, I have this data there, or if you have this case there, then go to look there, for example. I know that's how I look at it.
Well, no, what I was about to say is that if anybody wants to go back and rewatch the most recent episode I did with Rick Borden, a lawyer who's really focused on AI regulations, I think you'd be shocked at how similar what you just said is to many of the points that he made
Yeah.
about testing and documentation. And that's something that we've been thinking a lot about, though, is, and I think we even hinted at this a little earlier, is that how do we test these agentic systems? Because typically we know how to write test when we know what the answer is supposed to be. But what happens when you know what the answer is supposed to be like? It's we know what the answer should how what we know what the answer should be similar to. So when the probability, I guess that's a way of looking at it, the range of possibilities is not just one answer, it's a range of answers. um, you know how do you think we can approach testing these systems from that perspective?
Yeah, I think that if the output of a system is some kind of text is crazy ambiguous. So it's very hard to, yeah. English, as any human language, is super ambiguous. You have a different ways of expressing the same or conveying the same information. And then again, I look at that as the problem of if the output is some kind of a text, there has to be a certain number of metrics against that text will be evaluated. So I know correctness or consistency or coherence, such things. But again, for a different combinations of prompt and answer, I think different set of metrics should be there. So for example, if you have like factual answer, I know when is Daniel born, and you get like number there. So that has to be evaluated differently compared to, I don't know, what should I do tomorrow type of question. Like it's a fundamental different answer and fundamental different thing. And then how to actually, like how to build a system, I think somebody who's building the system has to actually list all these cases or like go through all of that and figure out, oh, for these type of things, this is working, for this, that. And then maybe like at some point you can have a generator for these things. So like just generate a bunch of different options there, not that you have to list every one if statement there, but kind of generate different cases and different answers and different metrics there. I don't know. That's how I look at the problem of evaluation and how to improve these systems over time.
No, that's an interesting way of looking at it, is that maybe that's kind of the entry point to solving some of these problems, is looking at this question only has one answer. This question maybe has a set of how big is the set of answers that it could possibly be. For instance, where should we go to dinner tonight? Well, that's a much more ambiguous question, but it's also, well, what's realistically nearby? I'm not going to go to dinner tonight in New York because I'm in San Francisco. So
Yeah.
we obviously need to bound that somewhat. So how do we bound those problems? And that kind of leads me to, where do we think this is all going? So we definitely think that testing, documentation, being able to crack open these black boxes, that's important. But where do you see AI driving knowledge graphs and agent integration for 2025? Or do you think something big is lurking in the shadows that's going to disrupt everything? Or have we already seen all the big technologies disruptions, and it's going to be things like testing and coming up with new testing evaluations are going to be the big newsworthy item?
Yeah. So maybe to step back. So with these LLM systems, I think efficiency gain or productivity gain is non-questionable from my perspective. So it's just like, yeah, people, you get faster, you get much faster answers to your questions in so many different areas. So that's not a question at all. And then I think with the graphs and knowledge retrieval systems, I think that's also pretty much in a much better state, because you have that tool called LLM, which allows you to, which is kind of like a catalyzer for all these things, because you can plug in like different knowledge in there and get really good synthesis of new knowledge there, or like new responses out. So I think knowledge retrieval as a category, I'm sure it's gonna be advanced massively, and there is like a huge gain there as well, because again, you have a bunch of data. All these now we have much better tools, or at least a few more tools, to make the knowledge retrieval systems faster. That's no questions. Agents, that's a bit of a problem, because evaluation problem there, and as soon as you have to interact with the real system, that's kind of challenge, because you really want to make sure that it's correct, or people are scared of autonomous actions and stuff like that. That's probably much more challenging. But again, for simple applications like some kind of summarization, prioritization, like many different ways of, I know I do a bunch of stuff, for example, where I need some kind of a summary, or some kind of, yeah, again, if you can tie the problem to a knowledge retrieval, that's where there is a lot of potential in the short run. In the long run, probably, yeah, different ways of evaluating the system and different integrations with real world systems. Because I think there is a really powerful set of things you can do, but yeah, integration has to be much better to actually make real world actions.
That brings me to the only word I can think of right now is I, we're talking about information retrieval and knowledge, and I can't help but ask about, you know, what do you think about people when they talk about the term AGI? And do you think that's something that's coming soon, or what does that even mean to you?
Yeah, that's when I was at university, AGI was kind of, oh, we will never reach that goal, because it was since I don't know, 60s or 70s where people defined that term. It was almost impossible. There was like some initial group of people defined that they will need 3 months to reach AGI or something like that. In 70s or something, I don't recall exact numbers, but and these days everyone is talking about AGI. I think, yeah, I think the biggest issue is this, again, hierarchical thinking, having a way of boiling down all these actions to very specific things. So, for example, I think Jan LeCun talked about that on Lex Friedman podcast, and I fully agree with that view. If you want to go to from, I know, London to New York, at some point you have to move a muscle to do something, and this requires so much more information and so much more control in the
Mm,
system that we just don't have not even close granularity on that side to actually make such systems currently. But yeah, definitely like a lot of advancements in the whole area. For example, the other day I saw that research group building like a muscle, like a really good material for building muscles. And yeah, building like a robot out of that, it's it's totally different game currently with that type of material. But then, yeah, eventually building all these blocks and making sure that, yeah, when it's the question, what's the AGI? I think to have something like that, you really need that, like a physical system
mm.
going around and figuring out like whatever human does. And again, AGI by definition is kind of a set of skills that only humans can, or like a system that would replicate humans there. But it can't be just, I don't know, a program which will run something. It has to be like a set of things, things you can do in the real world to actually make interactions and stuff like that.
That's an interesting perspective. So no chat GPT AGI anytime soon with that perspective.
Yeah, I think that's highly unlikely. I wouldn't say, speaking about probabilities, I would say that's highly unlikely that ChatGPT style AGI can exist. But when that thing is combined with another concepts and another tools, then maybe.
And to me, there's a simple aspect of, right now, the way we interact with these models is that, I have to initiate the request. Whereas, you know, somebody might send me a text message right now where they initiated the request. From my perspective, I didn't initiate that. So I think that's another thing that we're missing is when, when these model can all of a sudden initiate like, hey, it's like dinner time. Where do you want to go to eat tonight? Once it starts doing that, I think, and then maybe it start having more characteristics in line with that. And I don't know when that starts happening, and I don't know how people are going to feel about it.
Yeah, that's a good point. That's also the point. So with to make actions proactively, I mean, people have something called hormones and feelings. So you run so many things based on, I don't know, fear or happiness or something, and this is not modeled in any way currently in all these systems. There is no such a thing. So there has to be like much more complex system to actually initiate these things, because currently that's all initiated by humans running something, but system itself running such things, I guess, has to be much more complex and much more nuanced to actually run autonomously and proactively.
So it sounds like we're not, neither one of us think this is happening anytime soon, no matter how many GPUs and how much data and some of these people are scraping to do it.
I think we're making big leaps forward, but anytime soon it's highly unlikely. And even if there is a technology breakthrough, there is for sure regulations and stuff which will slow down the whole progress on that side. Because there is just like a fear of losing control.
Well, nobody likes hearing talking. Nobody wants to hear us talk about regulation. So that's a perfect place to end this podcast. Great. It's been great speaking with you, Marko. And no more talk of regulation. Nobody wants to hear that anymore.
Yeah, sorry, I didn't perceive that as a complex topic, but it is. Yeah, but anyway, thanks for having me here. This was like a great chat, and